Right, so here are your questions. Um, Firstly, looking at this, you'll notice that there are no distances or charges given in the usual thing you'd expect, like coulombs or meters or anything like that. So this is an exercise to try and get you thinking about ratios and try and get you thinking about using a formula without actually plugging all the numbers directly in, which is a skill that's really useful for you. So we've got three different charges, a charge Q, one which has twice that charge, 2Q, and one that has 4 times that charge and negative 4Q. Likewise, we've got two distances, just D and 3D. So one distance that's 3 times the other distance. That's it. There's nothing in meters or coulombs here to work with, but that's okay. And we also know that the force acting on the green one and the blue one, so the force of attraction between the green one and the blue one is F. Once again, we'll consider the blue charge, the resultant force on that. So the first question is, what's going to be the resultant force, the overall force on the blue charge? That's the overall force from the green one and the red one. And then the second question is, can you move this one? Can you move this one somewhere else so that the resultant force on Q, the blue one, is 0? So those are the two questions. So the first one, I'm looking for an answer as some multiple of f. So like, half f or 10f or 2.5f or something like that. The last one, second question, firstly just try and think of somewhere you could put it vaguely so that the resultant force on the blue charge is 0. If you can actually work out the distance it has to be away as well, that's even better, but don't feel like you have to do that if you can't manage it. So pause the video and have a go at these now. Right, hopefully you've had a go at those and sketched a few diagrams or something. Let's have a quick look. So, what's the resultant force on Q, the blue charge? Well, let's get the formula up so we know where we stand. F equals Q1 Q2 on 4 pi E naught R squared. Now we know that the force of attraction as a result of this green charge is F. How's the force, which is going to be a force of repulsion between these two charges, going to differ? Well, the charge, the magnitude of the charge is half, from 4Q to 2Q. If you halve one of the numbers in this, that's going to halve your force overall. So the force is going to be F, the same as the green force, times a half, because the charge is halved. But that's not the only thing that's different. Obviously the distance is different as well, and the distance is a third, so it's 3 times closer. Now the distance gets squared over here, so by bringing it 3 times closer, the force is actually going to increase by a factor of 3 squared, which is 9. So that's going to be times 3 squared, which is 9, which should give you 4.5 F. So we've got a repulsion of 4.5 F from the red charge. That means the overall resultant force on the blue charge is going to be F plus 4.5 F, which is 5.5 F to the right. So that's the resultant force on the blue charge. What about this one? Can we rearrange them so that the resultant force on Q is 0? And in particular, it was, can you move the green one so that the resultant force on the blue one is 0? Well, the red one is repelling it, so in order to counteract that, we need the green one to attract it by exactly the same amount in the opposite direction. So we need the green one to be somewhere over here. Okay, so if you've got the green one somewhere to the left, okay, then that's all right by me. Okay. However, if you want to know exactly where to put it on the left, then we better have a think. F equals Q1 Q2 on 4 pi, pi's a bit weird, sorry about that, E naught R squared. Now, the charge on this one is double the charge on this one. So it's going to have to go further away. If we put them the same distance, okay, then because the charge is double, the force is going to be double, and this force is going to be too big. The resultant force won't be zero. So this one must go further away. The question is where? If we were to put it 2D away, okay, then the force would be doubled because the charge is double, but it would be more than halved because the distance is double. Remember, the distance gets squared. The force would be quartered as a result of that doubling of the distance. So the force here, if it was 2D away, would be too small. This force would be too small to make the resultant force zero. So it's got to be somewhere between here, where the force is too big, and here, where the force is too small. And if the number we have to square is going to give us a factor of 2, so if the number we have to square, the distance we have to square, is going to give us a factor of 2 to counteract the charge, then this number here is going to be the square root of 2, which is 1.41 something or other. So actually the ideal distance for this to exactly give a resultant force of 0 is to 1 decimal place when the green charge is at 1.4 d. So don't worry if you didn't get that exactly, the 1.4 d or the root 2 d bit, but hopefully at the very least you got the charge in roughly the right place.